Hi and welcome back to a new video. Right now the 3090 Ti seems to not only potentially heat up your PCs because it has a very high power consumption, but it's also heating up some discussions. And for me, to be fully honest, I mean, just objectively speaking, the 3090 Ti makes no sense, but the 3090 already made no sense, and I still enjoy playing around with things like this because that's what we're doing most of the time on this channel. Not everything makes sense on here, and I guess the 3090 Ti is a similar product that's, objectively speaking, nothing you should buy, but then it's still kind of cool. So yeah, just being fully open here. I want to mod the card to a certain degree, but before we get to that, still have to open it, like completely disassemble it first. So there it is, the monstrosity. And to be fully honest, I absolutely love the ASUS Strix cards. Also historically speaking, because we did so many things with ASUS Strix cards, they always delivered, they always have very solid components. The PCB is always typically top notch. And like looking at this, I am very satisfied. Like this should be pretty much the same like a 6900 XT LC. I'm pretty sure it's like 99% identical. Really like this part, but what I don't like is this part. I'm generally not the biggest fan of AIO cooled graphics cards because they are better temperature wise than like air cooled cards, but they are far from competing with custom water cooled cards. And then you're always stuck with the type of radiator they decide for you, and like a 240 is always chosen for maximum compatibility with your case, but then like a 360 would be so much better for cooling because the pump is not the strongest, so you have to rely on cooling your water down as much as possible in the 240 radiator, and then yeah, it just could be better. There is already a review out there from Tech Power Up, and they showed that the temperature of this card is typically in the range of like 55 to 60 degrees Celsius, which is technically absolutely fine. Like nothing to complain about. But you also know that custom water cooled, you're more in the region of 45 to 50 degrees Celsius, and that is simply better. So there's always this kind of trade-off that you make because you want to have max compatibility. That's why you go for 240 instead of like 360, which would be much better cooling wise, considering that this is like consuming 500 watt easily. And that is a lot of heat to dissipate. That's why a 360 would be like my minimum choice I would go with, especially considering that's this is typically like a slim radiator. Yeah, okay. It is just a huge PCB. That's what I find like interesting about the 3090 Ti. If we just neglect everything like the power consumption and everything, but just looking at the PCB, I find it just pretty impressive. There is a new voltage controller, which I'm also in contact for with Elmore because we want to add EVC support very soon. Maybe I can help him adding the support, and at the same time we can maybe do something in this video. So I'm just in contact with him right now about this case. Apart from that, it's a typical Strix PCB. We have additional fan connectors in the back. We have this new power connector, which is present on every single new 3090 Ti. You have this adapter included if you want to. It's not the most beautiful thing, but it should just work. Apart from that, it's like interesting that we're going back to this double row power design, which I think used to be the case for some cards on like 780 Ti or like 980 Ti. Cannot really remember, but I've seen this before. It happened before. But what's also interesting is that this new power controller is not only powering the GPU, but also the memory at the same time. The huge black block, it's like aluminum injection molded part, is just there for cooling anything that's VRM related. Like all these thermal pads in the front and in the back make contact with the huge amount of VRM and dissipate all this heat. The GPU and also the memory make contact with this huge copper plate. And the entire block is cooled by this fan, which you typically see by looking through the shroud. Essentially, you have all these like fins in here. That also means that the entire fan is just responsible for cooling the VRM. But what I'm on about is this cooling plate. And if you compare it with the 6900 XT LC Strix, then at least this one is not using those very weird like triangle shaped screws. It's using normal Torx, so we should easily be able to remove them. I would assume that this is just the cold plate of the AIO, which also means that underneath, if we remove all the screws, there should be some fluid. That's why just doing it above this bowl to catch like leaking water. pretty interesting. I did not expect to have this like distribution plate directly sitting on top. I first assumed that just the pump would sit on top, but that is quite interesting. I would assume this is just for additional stability. We have the mounting in here with threads, because its steel should be a bit more stable than just copper. I guess my project, or like my plan, will be a bit more difficult than I expected, because this black thing is EPDM, which is the same material where all the O-rings are made of. And but at the same time, it's also convenient because we can keep this as like distribution plate for the water, because it also has the channels already included for like having the access in the center and then spreading the water to the side. At the same time, it's the steel. And my plan was to build like a custom water cooler using this as the cold plate. Have like an acrylic thing on top. Then we can maybe stick to the black part, like the aluminum cast part for the VRM, but have this to be able to include it into a custom water cooling. Because I think, to be fully honest, a 3090 Ti Strix with this power consumption and heat output, it deserves to be in a custom water cooling loop. Meanwhile, a few hours later, and you can see I already 3D printed this part. It's pretty much just a like space check to see if everything is in line with our rubber sealing. Mounted to our cold plate would look this way, so at least this would already fit. And my general design idea would look somewhat like this. We have one tube coming in, one tube going out, just normal EK tubing, EK fitting, just without the like compression part on top, because there's just no space. But this should still be fine. I can add some like cable ties later to make them secure, but that should be okay, I guess. And now I have to design the like remaining 90% of the block. My idea is that this will be the intake. It will flow through here, come back out here, and then like flow back through here. So yeah, but everything is extremely tight, so it's a bit of a challenge to design this, but yeah, I will see. Meanwhile, another day later, as you can see, we're printing another part because I have to do another like seating test, and if this is confirmed, if everything works out, we'll print the rest of the cooler. Yep. Okay, let's see if this fits or not. The first check I'm doing right now is with like a cut view. I basically printed this part again, but with the layer on top, and then just did a cut in the CAD to be able to check if everything with the sealing works out, because the left part will be the intake. You can see the intake will be sealed off to the top part, and this way, because I just want to utilize the full like O-ring sealing from the AIO, but this way it should work out perfectly fine. And also the big part fits pretty well from my perspective right now. There are some parts which are still missing in the CAD file, like the O-ring part on top and like screw holes for mounting the sealing on top. Everything that is still missing. You can also see that there's a huge gap on bottom, but that's because there's like no mounting pressure right now, because it would be screwed from the back. But I think that looks quite nice. And now with the big cover on top, you can see this fits really well, and I'm personally surprised, because typically like the first try you always get some measurement, something wrong, but the attempt is pretty on spot. There's a tiny gap in here, like 1 millimeter, but like 1 millimeter is 1 millimeter, right? It's fine enough space, enough clearance. It will be very tight with the tubing on top, but I think that should also work out as long as we first mount them inside the block and then like put this black thing on top, then it should all work out. So I will spend a bit more time, like I think like 3-4 more hours, like finalizing the thing in CAD. And then we can finally CNC mill this out of a piece of acrylic. Again, a few days later, I made some progress on the 3D part, printed it again with a few more details. I added all the mounting holes to the side, which will be necessary to mount the top part, to seal it off. Also like the O-ring is already present, so I have to do like some radiuses in here and here. There's also still all the support stuff in here from the 3D printing. Yeah, but that will just be for another test to see if everything fits. And then the next step would actually be milling out of acrylic. I think another 2 or 3 days passed, but as you can see, that's the first attempt in acrylic. But as you can also see, the G1/4 threads are still missing. We still have to add them. Yeah, and some tiny corrections on the side. Measuring the part for CNC milling is a little bit more effort, simply because that's something you won't be able to see with your bare eye, but this surface right here has an angle of 8 degrees to this surface. That was necessary for the fittings to be able to fit from the side because one will be slightly bent. Yeah, that makes the measuring now a bit more complicated, but I'm pretty sure that we will be able to fix this very soon. I guess not. Seems like something is not correct with the 0 because it tells us the part would be here, but it's here. Yeah. Looks like we have to slightly tweak some of the coordinates to make this work. Now the only thing that has to work out is cutting the thread. That is an awesome looking part. Now you can also see the angle difference between the fittings. The only thing I'm not 100% sure about is if I will be able to fit the O-ring in there, but yeah, only one way to find out. And now the only remaining thing is the top part to seal it off. I think we'll simply laser cut that quickly. I did a few more changes, also ordered new fittings and new tubing. As you can see, I changed to normal old school fittings without the compression on top, because originally I wanted to use these 1610 tubing from EK, the ZMT tubing, with the normal EK fittings, like the compression fittings. But then I figured out that this will not work simply because I won't have enough space like up here. That's why I ordered, in addition, these AlphaCool soft tubes. They have 13 to 10 tubing, so it's like 13 outer diameter and 10 inner diameter. So the inner diameter is the same as these, but I have a bit more spacing around the top part of the card. Then when the tubing will exit the card, I will add these AlphaCool fittings. Those are like rotary fittings, so I can attach them to the tubing and then have anything outside. That's the thinner AlphaCool tubing which I will use, and the changed fittings. So a bit more space in here. It will be a lot more convenient for me to install. One more change I did was I had to countersink the screws a bit more because I did a little fail in here. Originally my plan was to keep everything like 100% the same of the card, like you don't have to modify any parts of the AIO. But then I did a little fail because I think the screws they used for the AIO were M2.5, but I did M3, so I had to make the countersink a little bit deeper. That's not a huge change, and you could easily change the thread to M2.5. That would be no issue, but I would have to CNC mill it again. I didn't want to. That's why I simply changed the cold plate and countersinked it a little bit deeper. Apart from that, also did the top part, which is a simple 5mm acrylic part, laser cut it, also added a countersink in here. Yeah, almost ready to go. In the next step, I will start with assembly. Already placed the gasket on top. Now we'll add the acrylic part. Should fit spot on. And then use these M3x6 screws to fix everything together. This looks pretty nice. I'm very happy with the result. I also want to add, if you look from the side, I was a bit unsure at a certain point if I'm bending the copper part, because just if you look at the reflections, you can somehow get an idea that it would look bent. Then I completely disassembled it again, checked again, but it looks exactly the same. Then I had a precise milled steel part which I put on here to check if it's even or not, and it's always a bit convex, but it always was convex even without the mounting, so I guess that's maybe intended and also original. But if we check the sealing, like the O-ring inside, the gasket looks perfect. Like you can see the imprint on the acrylic, that looks pretty decent. And now to seal it off, I have to glue my own O-ring in there, so I have to put it in on the outer part and then glue everything, so that should be okay. And then I will have an additional O-ring in the center like this L-shaped one. That one is just to seal off this part from this one. It will not be 100% sealed, but it's just to have a disconnection between both of these chambers, but that doesn't have to be 100% sealed, so that should be okay. All right. Very, very nice. I am extremely satisfied and happy that everything worked out so far, no issues. I think it's also tight. I will probably just assemble a loop for testing and probably just run it overnight without putting it in the card, because otherwise I think that would be a bit stupid without doing like any kind of leak testing. But yeah, that will probably work out. We'll now add it to the loop, see what happens. This is pretty awesome because you can see all these tiny air bubbles, and like up here, because the exit on this side has an output on 2 directions, like on left and right. And then like in the center, you almost have like a dead spot. If you just look at these bubbles, that's pretty interesting. You can also see how everything goes in there in the intake. And so far, no leak. That is great. That is great. Meanwhile, assembled most of the card. The only thing that's missing is basically the cover on top, also attaching the fans. I first want to check though if the contact is proper, if we have good temperatures before I assemble everything completely, because otherwise I would have to do the entire work twice. But you can see most of the air inside the loop and everything is gone, but it's still not leaking, which I'm very happy about. Now check out my very professional test setup, aka I was too lazy to dismantle the system. That's the one we used in the previous video for testing the height case. But building the system, I used my Corsair 1600 watt PSU, which I need for testing of my 3090 Ti. That's why I simply put the card in there. But also quite handy that the cooling loop is using an additional PSU, so I can control it like independently. Sure, it's still an idle, but 31 degrees Celsius is already lower than what we've seen with the AIO cooling. So I guess we will just put it under load. Now checking again the temperatures after Temps by Extreme passed with GT1 and GT2. Looking at the GT1, it feels like it's 1 or 2 degrees Celsius colder. But to be fully honest, in GT2, it looks almost identical, because I also pretty much all the time saw about 57 degrees Celsius in the GT2. Now looking at these results, you could easily get the impression that this was a pretty terrible idea and it didn't help at all. Like looking at the temperatures, that's kind of true. But we also did noise testing with the AIO, and we typically had results of about 46 dBA with this under load, with the performance BIOS. And this was peaking out at like 36 to 37. And about 10 dBA is about double the noise level, which means that this is a lot more quiet than this. And that's exactly why we have the benefit of using a different pump and a different radiator, because obviously we're still using the same cold plate. We are still stuck to the same kind of like cooling structure because we use the same gasket. So the entire flow is still exactly the same, but we have a lot more radiator surface because that's also only an aluminum radiator. That's a copper radiator, a lot more surface area, lower fan speed, higher pump speed. Yeah, not even bad at all. Now I just want to see what's possible overclocking wise. And I want to point out that the entire time I was testing now with like the custom cooler, I did not use the fan to cool like the VRMs and the memories and everything. Well, the memories are cooled with a cold plate, so that's not true, but the VRMs, the entire VRMs are just passively cooled right now. And I think it's not even necessary to have the fan spinning, because even after cycling through Temps by Extreme like 4 or 5 times, this was like hand warm. So pretty solid PCB. As you can see with these spikes right here, so that's every time when the Temps by Extreme test just right crashes at the start, then we have like peak in the clocks and then it goes back down. But this was a stable run. And as you can see, it also sometimes peaks to 2.2 gigahertz, which is pretty amazing. But if we look at the performance though, and I think that's the entire thing with the 3090 Ti, I don't even think we have to talk about this, because I mean, generally speaking, this card with like so much more power consumption is like 2 or 3% in front of my 3080 Ti Founders Edition, which was also manually overclocked. But as you can see in the chart, the performance difference versus a 3080 Ti overclocked is so small, like it doesn't make any kind of sense. At least if you look at the additional power consumption of the 3090 Ti, really, yeah. We don't have to talk about that, I think. But the project itself we were looking at today was to test if it's possible, if you have an AIO cooled card, can you just take this card and the base materials that are delivered with the AIO cooling, like the cold plate and maybe the gasket, take these parts and mod this into custom water cooling without modifying the parts themselves. And that's definitely possible. The only thing which we modded in the end was the fact that we had to countersink the cold plate a little bit because we used the wrong screws. But if we adopted to M2.5 instead of M3, we could have used the same components without modifying them at all. And I think that's quite cool, because then you can easily do this. Like an acrylic block like this, manufacturing wise, costs maybe, I don't know, like 5, 6, 7 euro maybe. Doesn't really cost much. So yeah, only very little effort is needed to transfer a card like this from AIO cooling to custom water cooling. So that is actually quite cool. The only thing is that you have to keep in mind you cannot really revert it. Like going back to AIO cooling would be quite a bit problematic because the AIO is empty. You would have to refill it, which is not that simple. You can do it, but it takes quite a bit of like trial and error and a bit of time. It would be possible though. Yeah, so I enjoyed this video. I hope you enjoyed it too. Thanks for tuning in. See you next time. Bye bye.